Okay, so day 3, we're doing washers. Okay, so again, we're using a problem that basically we've done before. Okay, so again, I want to find this volume by revolving it around the x equals 0 line. So the x equals 0 line is basically our y-axis. Okay, so that's where my axis of rotation is. So when I find my bounded area, so the quadratic part is going to be, get back in my pen, is going to be, the vertex is at 2, 1, and this part here is the part of the quadratic we're going to be using. And then we're using this line here, from here to here, here to here. So this is my bounded area that I'm going to be using. Okay, and it's bounded by these functions right here. Okay, now I'm going to be I don't want to draw the rest of it because I'm going to be revolving. It's going to get messy. Okay, but again, I'm revolving it around this line right here. Okay, so to make it easy, I reflect it over. So here's these points, like this. So this is this side, and you can see right here starts getting that kind of 3D look. Okay, now here's the problem. So normally we would just worry about finding our outer radius and inner radius. The problem is that up here, my outer radius, this is my big R, and my inner radius is right here. This is my little r. But then down here, it changes on the bottom part. As soon as I get to this spot right here, now my outer radius, this is my big R, and my inner radius is from here to here. So because my function doing it this way splits right here at this point, I have to create two integrals. So I got to set this up twice. Okay? So let's look at the top part. And now the top part is basically from here to right here. This is y equals 1, and this is y equals 5. And then here, this right here is y equals -1. So we're going to have to split it up from -1 to 1 and from 1 to 5. So let's deal with this top part from 1 to 5. So in the top part, my big radius, the outside, this distance right here, this is 4. This is the y equals 4, sorry, x equals 4 line. And then the little radius, the inside piece, is going to be this function here. And we'll deal with that in just a second. So my big radius is going to be 4 minus 0, because we're dealing with the function on the right minus the function on the left. So the right side, this is x equals 4, this is x equals 0. Now the little part is going to be equal to the y value here, or the x value here, basically x minus 0. Okay, because this distance is my x distance, and it comes from this function up here. So you have to solve this for x. When you solve this for x, you get x equals plus or minus the square root of y minus 1 plus 2, which means this ends up being the square root of y minus 1 plus 2 minus 0, which is just that. Now we're going to use the positive side because this is the positive side. This part is the positive side. The other side would be the negative side. Okay? Now for my other integral, my big R of y ends up being same as the first one. The outside, or the big R, and still ends up being 4 and the left side being 0. But then the inner radius, or the smaller radius, the outside becomes that 2 minus 0. Okay? So the top part, the integral, when we finally set it up, is going to be the one from 1 to 5, and that ends up being 4 squared minus the square root of y minus 1 plus 2 squared dy. Okay? Now, again, if you FOIL all that out, you're going to get pi from 1 to 5, and then this ends up being negative 4 square root of y minus 1 minus y plus 13 dy. That's 5. And then you evaluate that integral, you take the antiderivative, then you evaluate it from positive 1 to 5, and you get this is equal to 56 pi over 3. Okay? Now, that's the top part. Now the second part, okay, that's the integral from negative 1 to 1, and that's this part here, which ends up being just 4 squared minus 2 squared dy, which is basically just going to be pi times negative 1 to 1, and 4 squared 16 minus 4, so 12 dy, which ends up being 24 pi. And then you add those two together, and it gives you your total volume. For my calculus kids that need the code for today, your code is D1SKS, and that's your code. D1SKS. Now, the hardest part about this problem is the fact that you have to recognize that there's going to be, you have to do two separate integrals here, because when your inner radius here changes from this function here to this function here, so you end up having to do two different integrals. If you had done the same one the entire time, it would have given you some kind of funky answer, because it basically, you would have ended up at this point, this side would have gone back up like that, and you would have had something that looked like this. There wouldn't actually have been a cutout in the middle. So you got to be very careful that you need to know to set up two different integrals when you're switching. Kind of like when we did area, you know, in the top or the bottom function switched. If we came to a point of intersection and that bounded area changed, it's the same thing here. If either of our radiuses change, we have to set up a whole new integral.